I think I got a pen that works here now. We're going to do just the same solving triangle stuff, only we're going to put some applications to it. Sometimes we know these are called just word problems. And there's nothing different except now we got to basically draw a picture and see what we're talking about. So first things, I guess what we'll do is we'll put some steps down, and then we'll do a couple definitions. So step one, draw a picture of the situation. So draw a picture, I guess in label, put all your lengths on, your angles, all that kind of stuff. Okay? And just watch, the question is, so if it asked for a side length and you knew two sides, you could use Pythagoras. If it gave you an angle and a side, maybe you have to use trig ratio. So I guess step two is figure out what technique, we'll call it, you have to use to to answer question. Okay, so I guess that entails the 180 rule. We know another possibility is Pythagoras, if we can use that one. The other part would be trig ratios. So you might have to use all three of those, or one of those, or two of them to figure out what it is that you need to do. Okay, so we'll do an example. So I know it seems, I guess we won't do the example right away. We'll do definitions. So let's go here, definition. And you would have got these in grade 9 anyways, but just a refresher. Angle of elevation. Okay, well, the angle of elevation is just simply the angle created from the horizontal when looking up. It's simply like that. If you were standing right now and you were to stand up and raise your head to look up at the roof, you've created an angle of elevation. So I guess in a picture form it would look like this. Here's our horizontal, and if I look up, this angle right here that I'm drawing is my angle of elevation, right in there. So whatever that might be. So angle theta. So pretty simple. Well, the angle of depression then is the opposite of that. Instead of when looking up, you should be able to think, well, when looking down. So the angle created from the horizontal when looking down. Okay, so again, I'll draw a horizontal line. Pretty sweet. And if I were to lower my head to look at the floor, I would create an angle looking down like so. So there would be my angle of depression. Now, what's unique about these two pictures is that if I drew them, I just got to erase the board here. I know it looks like it's erased on your end, but it's really not. So erase this, and I'm going to draw a picture and show you guys a situation. Let's draw a triangle of a helicopter, or let's draw a picture of a helicopter here. Oh, look at my fancy helicopter here. Okay, so now, if we were to think of the horizontal coming off of a helicopter, like so, and the ground being here, if I got some airport building right there. So here's the airport. Here's my helicopter. Well, if I drew a triangle down to the airport and straight down, so we got the height or the altitude. Let's make it 3,000 feet. I think you might have a question like this in your assignment. So 3,000 feet, like so. I guess I'm just going to make this a bit bigger like so. Well, the same if I were to draw this vertical here down. This is still 3,000 feet here as well. So no matter where I draw it, it's going to be the same. Well, the other neat thing about this, if we went and said that the angle of elevation right there is 40 degrees or something to that effect. I'm just going to put another pen together here so I can do this. Okay, so if I said that is 40 degrees, like so. Well, the angle of depression from the horizontal coming down would be the exact same. So no matter how we draw this angle, come in. Hey! 40 degrees. Hey, Al. 40 degrees, it's the same. Okay. Alrighty. So now if we had to figure out a simple question, let's see an example like this. So just a refresher there again. The angle of elevation and the angle of depression are really the same. They're just in two different spots. So real quick, the sun is at an angle of elevation of 42 degrees. Okay. The shadow of a tree is 14 meters long. How tall is the tree? Now again, this isn't anything different than what you did in grade 9, okay? But we'll draw the picture out here. I'm just going to see shadow of a tree is 14 meters long. How tall is the tree? Well, here's my tree. Like so. Pretty simple. Well, if I draw the shadow and say, okay, the shadow, all shadows lie on the ground, by the way, not in the air, okay? And let's just assume that this is the end of the shadow, okay? And the sun, way up here, boom, 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 and it casts light on this tree. And beyond that tree is dark, which creates a shadow. Well, we know that the angle of elevation to the sun, we said, was 42 degrees. Like so. Well, now I can figure out, okay, what can I use? And I'm trying to find how tall the tree is. Well, I drew my picture. I've labeled it. Now, what can I use? I can't use Pythagoras because I don't know what the hypotenuse is, because all these triangles are right triangles. I could use 180 rule, but that's not really going to help us find the height of the tree. But trig ratios, if I name my sides from this angle right here, this 42 degrees, the important angle, well, I realize that this here's my opposite, and this 14 is my adjacent. So the x is my opposite, the 14 is my adjacent. I figure out, hey, that's the tan ratio. So if I said the tan of 42 degrees is equal to, we know it's opposite over adjacent, so x over 14. And we all have our steps from the other day where our unknowns on the top, so I'm going to multiply the 14 up, and I get x equals 14 times tan of 42 degrees. So, how tall is it? Well, real quickly, 14 times tan 42, we get 12.6 meters. So that's just one simple type of question, and I know Mrs. Myden loves trig as much as I do, so she could help you on this pretty easily. So I'm gonna leave you alone, and you guys can battle out some. There's some tough questions on there, so whatever you guys can't do, you can leave, and we'll take it up tomorrow.